couple weeks, we've been talking a lot about powers and base 10, but today we're going to focus on lesson 5 and 6 in topic B and kind of start moving on. So if we first take a look at our standard and objective, you can see in your objective we have you're going to use and you're going to apply the rules of exponents, including powers of powers, powers of products, and powers of quotients. So we're going to start moving into, and again, this is in topic B in your book. We're going to start really diving into exponents and exponent properties, including those you see here. And as well as that, you're going to use those properties that I kind of talked about to write some equivalent expressions. So kind of be thinking about equivalent expressions and what those are. And then this is your newest standard, 8 EEA1. Asks you to know and to apply the properties of integer exponents to generate equivalent numerical expressions. So generate is like to create or even to write. So kind of keep these things in mind as we are going through the lesson. So today's lesson is going to be a little bit different. Since I'm not there, we're going to work on this lesson digitally. So if you're in your book, this is on page 77. So I'll write this here. Okay, this is on page 77. Through the use of this video, I need you guys to make sure you're just watching and make sure you're also taking the same notes that I am so you can keep up with where we are. At any point, feel free to stop the video, pause it, write what you need, rewind, do whatever it is you got to do, but make sure that you are really engaging and really doing your best during this time as we're doing some virtual learning. So in lesson 5, if we look, lesson 5 talks about products of exponential expressions with whole number exponents. So if we think about the word product is what? Product is when we're multiplying. So it looks like we're going to be doing some multiplication with some exponential expressions. We see the word exponent there, and then we've got the word exponent again. So it looks like we may be doing a little multiplying with some exponents. And if you start looking through, you can kind of see that happening. So if you look on problem number 1, we see that on problem number 1, it says to multiply. Write, and you're having to write, the product as a power of 10 in exponential form. Well, we haven't seen that in a second. It's been a little while. But let's kind of take a look at what that's asking us to do. What I'd like for you to do is kind of take and pause the video and generate what you think for number 1. After you've taken a minute to kind of look at it, if you look and see, on number 1, we've got 10 to the power of 50 times 10 to the power of 20. And those are some pretty big numbers. So kind of be thinking about what you think that's going to look like, because it does say to write the product as a power of 10 in exponential form. So when we write the product, we're wanting to write the answer to this. If we kind of keep looking down, if you look on number 2, okay, when you start moving on to multiplying powers with like bases, we see that word base for this section, and it kind of says to do the same thing. Multiply, and you're going to write the product as a power of 10 in exponential form. If you look on this one, the only difference is that you have 10 to the 5th and 10 to the 2nd. Well, those aren't as big of numbers, so we maybe could write that down. So 10 to the 5th would be 10 times 10 times 10 times 10 times 10. And then if we write 10 to the 2nd, I'm going to try to fit this right under here. That would be 10 times 10. So we have quite a bit going on, but if you really take a look and see how many 10s do we have in all? We have 1, 2, 3, 4, 5, 6, 7. So we can write this as 10 to the power of 7. We just simply took and added all of those 10s together that were listed. So that draws me back to the problem before. If we're looking at the problem before and we use that same idea, 10 to the 50th times 10 to the 20th could simply be done by writing 10 to the 70th. Well, where did 70 come from? Let's make sure we know where that came from. That came from doing that 50 plus the 20. Kind of interesting. So if you kind of take a look at what we're doing, the very similar thing between all these problems is they all had a base of 10. They had the same base of 10, and we simply just took and added the exponents. This is the first property that you're going to learn about, and we're going to write it down here in just a minute. So with that being said, let's go ahead and look at that final problem, number 3. It says to do the same thing. We're going to multiply and write our product as a power of 10 in exponential form. Well, I see that we have the same base, 10, and then we have multiplication between them, because it does say to multiply. All right, so I've got the two exponents, so I can say 10 to the 57th plus 342nd, rather large numbers, but don't let those bother you. That would be equal to 10 to the 57th, well, no, not 57, excuse me. That would be equal to 10 to, give me just a second. That would be 10 to the 399th. Sorry, my pen stopped working. 10 to the 399th. I'm going to circle both of these in yellow, actually in green, to show that these are actually some equivalent expressions. These are representing the same thing. Really, all three of these are representing the same thing. That's very important for us to mention. So if we kind of think about that for a second, and we go and look, okay, if you go to your book, okay, if you turn in your book to page 81, you can kind of see on page 81 here, oh, there it goes. There we go, perfect. You can see on page 81 down here that we have this little chart, and it is called the Properties and Definitions of Exponents chart. We're actually going to be working with this chart for the next 4 lessons, and we're going to be working on filling it in over the next 4 lessons. But what we're going to do is start by filling it in with the first property of exponents, and that is the product of powers. So I'm going to write that in, and you should be too. It is the product of powers property. This is the first property of exponents that we're going to learn. And the way the property goes is that if you have a base with an exponent times, very specifically I'm saying times right here, a base with another exponent, notice the bases are the same, you will take and just add those exponents together. So we have x to the m times x to the n equals x to the m plus n. Okay, make sure you're kind of seeing what I'm doing there. Okay, we have the same base, and they're multiplying, so you'll just take and add the exponents. So for example, we can actually look at one that we just did. We can say 10 to the 7th, not 10 to the 7th, excuse me. If we take 10 to the 5th and add it to 10 to the 2nd, we get 10 to the 7th. So if you have like bases, then you just, and multiplication between, you'll just simply add those exponents. All right, and something else that I keep mentioning the word base and exponent. I want to make sure that everybody knows about their vocabulary. So I'm going to erase that real quick, and I'm going to write a quick example up here, and again, you should be doing the same. Let's say I have 4 to the power of 3. I want to make sure everybody knows their parts of their exponential form. So the 4 here, this is the base. The 4 is the base, and the 3 is the exponent. Okay, again, just making sure everybody sees that and can see the exponent vocabulary that we're going to be using, and everybody is going to be using this vocabulary going forward. So I'm going to go back to that property just one more time, make sure I explain that good. Okay, if you have 2 bases with multiplication in between them, you're just going to add the exponents. That is called the product of powers property, and you want to do this when there are, you want to make sure you're doing this when the bases are alike. So I'm going to add that kind of on there. You want to make sure that you have like basis if you're going to do this property. All right, so if we go back, we've got several examples here. At the bottom it says for problems 4 through 14, you're going to apply the property of exponents to write an equivalent expression. So like I said before, okay, we're talking about equivalent expression. We said these were equivalent expressions right here. So on number 4, if you want to take and try and do these on your own, please pause the video, do them, and then go through with me as you check them. But if we take a look at the first one on number 4, we see that the base is 5. Okay, the bases are alike, and there's multiplication in between, so you'll just simply take and add the exponents. So this could be rewritten as 5 to the 3 plus 4. Okay, so right now I have generated an equivalent expression like it asked us to. I have written an equivalent expression. You could go even further to write this as 5 to the 7th power. Okay, the two expressions I wrote in red, these two are equivalent to the beginning one. So make sure that you're showing the steps, even though we know that 3 plus 4 is 7. We want to make sure we show that out so that we are showing more than one equivalent expression. Again, if you feel like you know what you're doing, take a minute, pause, and go through problem 14 and write the answers to them, and then you can be checking in just a minute. On number 5, I see the bases are alike, -5. So I can go ahead and write that one. And notice they put the negative in parentheses. It's very important that you keep your negative in parentheses. I see the multiplication in between, so I can simply just add the bases. And then this would be equal to -5 to the 16th power. Again, make sure you're writing both of those statements. Number 6, notice this one has negatives and fractions. Anytime you see a negative or a fraction, we definitely want to keep those in parentheses. It just makes things a little bit easier to deal with. Add those exponents, and this would be equal to -2/3 to the power of 12. Perfect. Now we get to number 7. I know 7 looks a little bit weird because your base is a variable. Remember, a variable is just a fancy way of saying an unknown value, normally represented by a letter. The base on this one would be y. Y is our base. They are the same, so we can just keep one base, and we would simply just add the 8 and the 11. We're adding because of that multiplication in between. So there's one equivalent expression. We can write another equivalent expression of y to the 19th power. All right, so kind of seems like we're getting the hang of it so far. If we continue on, we go to the next page. Okay, we're going to start kind of hopping through these quite a bit. We're not going to do every single problem, but I do encourage you after the video is over to go through and do several of them. If we take a look at one like number 11, I want to just skip right ahead to number 11. I'm going to choose a highlighter there. On number 11, I see that this one, on number 11 that this one has F and F. So our base is F. We got that much. We know that the base is going to be F. We also see that they are multiplying in between. So we know we're going to add the exponents, but there's only one exponent. So anytime you have a base with no exponent, there's always an imaginary little number 1 there. So keep that in mind, that if you don't see an exponent, you can just assume that there is a 1 there. So this would be f to the 10 plus 1. That's one equivalent expression. And then the other one would be f to the power of 11. So again, keep that in mind as we are going through. I want to do one more on this page, or on this little section, number 15. We'll stop right there. On number 15, I see that it says to solve for x. So we want to find out what x is. I see we have 7 to the power of 4 times 7 to the power of x equals 7 to the power of 12. Well, if you think you know what to do, pause the video, write down your answer, and then we will kind of come back and look and see. But I see they all have 7s, so that's one thing we can kind of see. You may even cross all the 7s out. And then take a look and see. We've got multiplication, so we know 4 plus x equals 12. This is one way you can think about this. Well, if you want to solve for x, you want to do the opposite operation. So we can do 12 minus 4 to get our x, which is 8. Well, let's check that just to verify and make sure that it is right. So I can go in over here, up at the top, and I'm going to write 7 to the 4th times 7 to the 8th equals 7 to the 12th. Same base, multiplication in between, that would be 7 to the 4 plus 8, which is equal to 7 to the power of 12. So we know we did this right. Hopefully right now you're feeling this is a very, very easy property. All right, let's continue on. Let's move down here to the bottom. So remember, I said if you want to use that property that you have to have like bases. So let's talk about what's going to happen when you don't have like bases, because I know somebody out there is probably like, well, what am I supposed to do? Well, let's talk about it. Well, now let's talk about unlike bases. Remember, the base is the big number. So if you look, it says on problem 16 through 22, we're going to apply the property of exponents, to write an equivalent expression. So we're doing the exact same thing we were before. Okay, but now we just don't have like bases. So let's take a look at number 16. When you don't have like bases, you're just simply not going to put like bases together. So I'm going to do this in 2 separate colors. I encourage you to do the same. Maybe use your pen that I gave you that's got the different colors on it. And I'm going to start with red. And I'm going to put together the values that have the same base. So I'm going to box these 2 in red, and I'm going to box these in blue. I also want to make sure that I point out that there is multiplication between all of these. So because I have like bases, I have multiplication in between, I'm going to apply the product of powers property. So I will do 9 to the 3 plus 4. Okay, wrong color. Let me not do that. Let me keep everything the same. Try to be consistent. So we're going to have 9 to the 3 plus 4. And then we're going to multiply that by 4 to the 2 plus, we're missing a number. Well, we know that's supposed to be a 1. Good job. Even though I didn't really hear you say it, I believe you said it. Alrighty, let's keep going. So this one, if we simplify it, would be 9 to the 7th. And then we'll have times 4 to the power of 3. Now, I'm sure some of you are probably asking yourself, what am I supposed to do now? Nothing. At this point, you are finished. Because the bases are not alike, we're not going to do anything else with those exponents. That's quite literally it. So I'm going to zoom this out. Okay, you are finished on that stuff. Now, I know we didn't go back and do the other problems. I do encourage you when the video is over to go back and look at those a little bit. All right, so now if we keep on going, we're on page 79. We're continuing on with this section of the lesson. You can kind of see what we're doing here. I'm going to focus just on 2 problems for now. We're going to focus on 17, and then we're going to focus on 20, and then we're going to go focus on 21. Alrighty, so we're back at it. I'm going to use my 2 colors again, and let's go look at problem number 17. I'm going to put together the things that have like bases. So I see that they all do have times in between them, which is very important to note. Okay, so I know I'm going to be adding some exponents. So I'm going to circle these 2 with a -2 base. And then I'm going to also, in a different color, I'm going to put together these. So I'm going to put my -2's together, and I'm going to add 2 plus 3. Then I'm going to put times in between, 19 to the 5 plus 7. All right, and then you just simplify. This will be -2 to the 5th times 19 to the 12th. Again, at this point, when the bases are still not the same, that is it. That is the end of your problem. Don't forget to put parentheses around those negative exponents. All right, I'm going to come down here. Same thing. Oh, one more thing. Let me go back. All right, one more thing. I'll go back. I'm sure some of you may be asking yourself, doesn't matter what order we write it in. Can I write the 19 first? Yes, you can absolutely swap these around if you'd like to. This could be 19 to the 12th times -2 to the 5th. That's fine too. Okay, either one. And I know someone's like, that's the commutative property. If you said that, you'd be right. All right, let's keep on going. Just a couple more. So on this one, same exact thing. But if you look, there is only 1 base of 4. So what do we think that means? If you said just bring it down, you are exactly right. All right, you'll add the 4 and the 5, and so we'll have 4 times 10 to the 9th, or 10 to the 9th times 4. Either one. All right, one more problem. If we come down here to number 21, we got some fancy schmancy stuff going on here. So let's take a look at what we got. I encourage you again, as often as you can, pause the video, kind of see what's going on, and then check your answer here in a second. On these, we don't just have bases. We also have what's called a coefficient. So I'm going to, over here on the side, and I, again, encourage you to do the same. Let's talk about what a coefficient is. So you've learned what a coefficient is before. It's just been a long time. A coefficient is that number that's stuck right up next to the variable. So in 2x to the 6th, the coefficient would be the 2. I'm going to draw a little arrow right there. The coefficient would be the 2. Okay? They're multiplying with one another. Now that we've got that, let's go and take a look at the problem. We have 2x to the 6th times 3x to the 5th. Well, I definitely do see some things that are the same. I first want to take and work with my coefficients. I'm going to take that 2 and that 3 and I'm going to separate those. Then I see that we have x to the 6th, we have x to the 5th, we have like bases. So the 2 and 3, we're not really worried about those right now. That's why I pulled those away. And that's why I'm looking at the bases, right, of x and x. So we have x to the 6th times x to the 5th. Okay, now that you got them separated, this is probably a little bit easier to see and work with. So I'm going to first simplify my 2 and my 3. This is just plain simple math. 2 times 3, that would be 6. So that's going to be the coefficient that's on our answer. Now with the other two, got some other business going on. These are like bases with multiplication in between. So we can just take and we can add. So x to the 6 plus 5. And then if we put it all together, this would be 6x to the 11th. Like so. So don't let there being coefficients bother you. Just simply remove the coefficients from the base. All right, so at this point, that's going to be the end of lesson 5 for us. Now let's move over to lesson 6.